In this video we're going to consider products of trigonometric functions. So in this first example we're going to look at an identity for the product cosA, cosB. The identity comes in this form with a 2 in front, but of course we could divide across by the 2 and consider the product of cosA and cosB, where A and B are any angles. Anyway, this identity says that 2 cosA cosB is the cos of the sum of the angles plus the cos of the difference of the angles. Now to prove this, we consider the compound angle identity for cos of A plus B. You can look this up. It's cos A cos B minus sin A sin B. So we need to bring in cos A cos B. So that's why we use this identity. But then we look at a closely related one. That's cos A minus B. And that's cos A cos B. We just change this minus sign to a plus. Notice that we can now add these two together, because if we add them together all the signs will disappear and we're left with just the products cos A cos B. So basically we look at this equation here and add cos A plus B onto the left hand side of it, that is onto cos A minus B, and add all of this expression here onto the right hand side of it. So we're adding the same thing onto both sides of this equation, so we haven't changed anything. So we get cos A plus B plus cos A minus B equals, well, these go out of course, add these together, we've got 2 of them. Now there are 3 other identities for products of functions. Here's one for 2 sin A sin B. Here's one for sin A cos B. And we have another one for cos A sin B. Now we proved this one here in a very similar way to how we proved this one here, using an identity for cos A plus B, but and cos A minus B. But instead of adding as we did, we actually subtract. And if we subtract, instead of the sine terms cancelling, the cos terms will cancel, and we'll have this term here. So when we were proving this, we added the identities for cos A plus B and cos A minus B. The sine terms cancel out. If we subtract, the cos terms will cancel out, and we'll have this. So it's very similar to what we just did. We just subtract instead of add, and we'll get this result here. Now what about this one here? Well, here we have a product of sine and cos, so that suggests that we use the identity for sin A plus B. And then what we do is we look at sin A minus B, because you see sin A minus B is also coming into this. We just change this plus to a minus. Now you can see that if we add these 2 equations together, these terms will cancel out. So we get sin A plus B plus sin A minus B equals 2 sin A cos B. We have 2 lots of sin A cos B, and we'll have this here. Now what about this one here? Well, we could take the 2 equations that we just had and instead of adding, subtract them. See, we have to subtract the identities and we'd end up with this. Another way you can get this identity here is to start with this identity and interchange A and B. So sin A becomes sin B, cos B becomes cos A, and we'll have this here. So I'll start with this and interchange A and B. So we get 2 sin B instead of sin A, and instead of cos B we have cos A, and that's exactly the left hand side of this identity. Let's interchange A and B. Well, it won't make any difference here because we're adding. But if we interchange here, we're subtracting, so we will see something new. Yeah, so I've just interchanged A and B here. There should be a plus sign, of course. So we're just looking at this here. Interchange A and B. So when we do it on the left hand side, we'll get the left hand side of this new identity. So now we have this here, and hopefully it's the same as this. Let's look at the sine of b minus a. Well, we can factorize a minus sign out of this. And we'll have minus b in here plus a. We take out a minus sign, of course that's the same as a minus b. So we have the sign of minus something negative, but we know that the sign of minus x is minus sine of x. That's from negative angles. So this here is the same as minus sine of a minus b. So we can replace this here with minus sine a minus b, and that gives us this identity here. So that's where that minus sign is coming from. Cos A plus cos B equals 2 cos A plus B over 2 cos A minus B over 2. So here we have a sum of cos functions, and we can actually write it as a product of cos functions. Now we've just proven this identity here. I've just changed A and B to X and Y. So we're going to use this identity to prove this one. So you see we can compare the right hand side here to this here, but X will be A plus B over 2 and Y will be A minus B over 2. So that's why I don't write down 2 cos A cos B here, because I want to equate this angle with this angle here. Obviously I can't equate A with A plus B over 2, makes no sense. So I'm writing down a more general form of the identity that we proved, just making a change of variable. So the more general form involves letters other than A and B, of course. Anyway, X is A plus B over 2, Y is A minus B over 2. So, we know that this is true, we've proven this. So if we make these substitutions in here, we'll get this side. If we make them on the right hand side, hopefully we'll get what we have over here. So let's do that. So we have 2 cos of x, where x is a plus b over 2, times the cos of y, where y is a minus b over 2, equals cos of x plus y. So we have to add these two angles together. What do we get if we do that? Well, we have a over 2 plus a over 2. Well, that's just going to give us a. But then we have plus b over 2 minus b over 2. That'll give us 0. So you can see that x plus y does indeed give us cos A, and that's what we want here. And then we have the difference of the angles. So we've a plus b over 2 minus this. Well, a over 2 minus a over 2 will give us 0. And then we'll have b over 2 minus minus b over 2. Well, that's going to give us b over 2 plus b over 2. That's 2b over 2, which is b. So we've now proven this. Now there are other identities that are similar to this one. This is a sum of cos functions. We also have a difference of cos functions. It's cos A minus cos B. I'll write this one down. Equals minus 2 sine A plus B over 2 sine A minus B over 2. Okay, I won't bother proving this one. We also have sums and differences of cos functions. So we have an identity for sine A plus sine B. Again, it involves half the sum of the angles and half the difference of the angles. So you'll see these in tables. There's one for sine A plus B. There's also one for sine A minus sine B. So there's 4 of them. I won't bother going through them. You can just look them up. You prove these identities by using the identities we proved earlier.